Hi, how you doing? You may have seen me in another room here at this conference earlier today. Matt Tavis, Solutions Architect for AWS. I spend most of my time actually talking to customers about what they can and can't do on the cloud. But today I thought I'd talk a little bit about disaster recovery mostly. The storage is a little bit of just an intro, like sort of part of the problem of disaster recovery, like where you back things up to. So we'll talk about that, and then we'll cover some DR, different scenarios we've seen customers apply to the platform. And then if there's time, we might get a question or two in there. So we'll see. All right. So the first thing I think to think about is really that this is part of a continuum in my mind, right? There's high availability, which is I want to run my app and never have it go down. But as we all know, that there's only so many nines you can pack into high availability, right? And each 9 after the first few really starts costing a lot more, right? It's kind of like a 10x multiplier. It's like every extra 9 after those first 3 or 4 gets to be really expensive. So fundamentally, high availability is one big piece of your application, but you have to think about what am I going to do for that 0.01 or 0.001% of the time when a true disaster does occur. And so, we think about this honestly in our platform as really a continuum across the whole thing. So, number 1 is high availability, 24/7, right? Keeping it up all the time. Number 2 is how do I make sure that my data is really safe in the event of a disaster? What's my storage story over time for true durability of that data? And then how do I get an application back after a major outage, or if my site goes down and it's that 0.01% of the time that I can't account for? How do I deal with recovering, right? So disaster recovery. So DR is really one end of that continuum, and it's defined by, how you choose to do disaster recovery is defined by a couple of things. These are the most common, terms you'll see here. RTO and RPO, right? Recovery time objective, like how long am I allowed to be out or down? And recovery point objective, which is how in sync is my data have to be to what was happening in my production system, right? So those are the two things that are really going to define what type of approach works for you or your application. These are not technological terms. These are business terms that you need to think through. What's my RTO for my company? What's my RPO for, this particular piece of data, right? It's not to say that, your RPO doesn't mean that you're going to lose your data, forever. It may be that, once my production site comes back up, I'll have access to it. But you may say, well, how can I function for that 0.01% of the time? How accurate does that data have to be for it to be acceptable for my customer base? And how long can I have an interruption? And what's an interruption look like? Is it complete site outage, or is it, it's the Twitter whale, the fail whale that sort of floats and says, we'll be right back. What's the right answer? And there's some continuum there along the way. So those are two things you'll have to think through, and those are business choices, and that'll define kind of what path you take. So, the goals really, are to obviously recover as soon as fast as possible, as is acceptable from a business cost perspective, right? So in the traditional, IT model, there's a couple models. There's, DR is generally off-site. It's a whole nother data center. You got your production site, and then there's some other data center that's, perhaps gathering dust that is available to you in the case of a disaster, and you have a plan around how to get there. There's two types, right? There's sort of low-end DR, which says it's really much more about just backup. Like, I make sure my data is there, and yeah, it could take days potentially to get new servers brought into that environment. Or there's your full hot site DR, which is, no, literally they're ready, they're running, they're plugged in, they're not taking traffic perhaps, but they're ready to take it in the case of an actual failure, and I've got, really expensive, high throughput bandwidth connecting the two kind of thing. So there's kind of a large spectrum there. So we'll talk about some of that stuff as well. So there's some interesting things that, we do from an infrastructure perspective that can change how you think about DR from in the traditional way. We can satisfy that continuum from the low end to the high end. We can be your hot site, as another data center that you have access to that you're synchronizing with in real time. We can also be that low end site that says, we've got all your backups, but you're going to have to spin up infrastructure on demand. The one thing that is interesting is obviously, you don't necessarily, because you in a cold site kind of backup model, you might have had to pre-purchase hardware in the traditional model. In the AWS model, you only pay when you turn it on. So that means that your cold site's significantly cheaper because you're not necessarily owning those servers all the time. You're only owning them when you spin them up to actually start serving traffic in a disaster scenario. The data's been pre-positioned, but the servers aren't actually running, so there's no actual cost around instance hours. In the AWS, we encourage a little bit of rethinking here. So number one, everything is off-site and potentially could be multi-site, right? So the other thing to think about is that when you have access to an AWS platform, you're not necessarily thinking about in terms of, where is that exact data center. You pick a region, right? But in a region, say the US East, for example, you have 3 availability zones, which means you literally have access to 3 completely distinct data centers. We're talking different buildings, different power grids, different floodplains, different network connectivity, right? So you have, in a single API set, have access to distribute a footprint across a large number of distinct data centers, which are, in our terms, called availability zones. In addition to that, you have access to multiple regions as well. So there's no reason why your DR site has to be on the same coast. You could say, well, I could use US East, for my main production site, and then I might replicate data into US West for my failover scenario. Obviously, as you go further and further away, latency becomes an interesting challenge. How do I get my data there, fast enough? But fundamentally, the infrastructure is available to you. So I think that's a key distinction there. And then, of course, we tend to, at least from Amazon's sort of background, and our tendency is actually to think about not so much a cold site, but a whole bunch of always-on sites that are taking distributed traffic. So your then impact is less of a single data center going down, taking down your whole site, and you have to do a complex cutover scenario, but rather, perhaps actually sort of spreading your traffic between multiple sites so that when a site goes down or a data center goes down, you're cutting over in the sense that you're adding more resources to the AWS side, but you're not necessarily not taking traffic during that period. You're using the AWS infrastructure as a hot site and taking traffic maybe at a diminished capacity for a short period of time. So that's another way to sort of think about how you can actually rethink maybe what DR is, as opposed to having a cold site somewhere. Maybe it's a hot site. And so obviously with this platform as a whole, the couple things to point out is obviously you can do HA, high availability, say within a region, where you're doing real-time replication, synchronization between all sorts of database nodes. Multiple data centers are being deployed or being leveraged in an availability zone model in a single region, and your DR site is just another region, right? So your up and running production has multiple data centers, high availability in the US West, and then should something occur, you modify DNS and point to US East as your failover zone and your DR zone. So that's all available through the same API set, so that how you manage it, how you access it, how you spin it up stays the same. It's just you're targeting a different service endpoint. Obviously looking at that, you have to sort of step back and say, well, that's great. What are these regions and availability zones, and where are they? We have 6 regions to date. And I happen to have a button pushing problem. Too much coffee, perhaps. So we have 6 regions to date: US East, US West, Japan, Singapore, and then European West region, and then our new GovCloud, our most recent region that we've added, which is then ITAR compliant. Obviously, the other 5 regions don't have the same configuration or setup as the GovCloud region. So if you need to be, ITAR compliant, application, then you'd be able to use GovCloud, but you wouldn't necessarily be able to fail over to the other ones, necessarily based on compliance restrictions. But we do provide that infrastructure. And the API set, how you call things, how you spin up servers, is consistent across all of them. And within a region, there's multiple availability zones, and as I mentioned, that's multiple data centers. These are physically distinct buildings. So if we have 2 data centers that share a parking lot, that's not good enough to be 2 availability zones, because 2 AZs or 2 data centers that share a parking lot are going to share a power grid, right? And that means that if there's a major power event, that power provider, not in our control, but they decide to not provide power to that section of the city, well, guess what? You just knocked out 2 availability zones, which isn't good. So we keep them distinct enough that we can actually isolate from those kinds of external events, networking events, power events, disaster zones, if possible, as much as possible. So we do spread those out. The first thing to think about is backup, right? So let's say I have, I want to do disaster recovery. I'm worried, where's my data going to be safe? And there's a couple different types of storage mechanisms, and they have some basic durability built in them that kind of helps you understand how to put your stuff in a safe place. S3, is the most common backup method, if only because it's accessible from anywhere. It can easily be accessed over the internet by SSL or regular HTTP endpoints. We have encryption features on that you can turn on. On top of that, you can actually encrypt it before you store. It's highly durable. It's actually targeted at, the number on the site is 11 nines of durability. That means that if you had 10,000 objects in S3, it would take 10 million years to lose one of them, right? So, I'd like somebody to wait around and test that out for me. Yeah, it's obviously a lot of durability baked into it because we replicate we replicate that data within a region, right, across multiple data centers. So we have multiple copies. We're doing checksum validation against all the copies to make sure that they're all the same as the source, and then we're re-replicating as appropriate to make sure that we have availability of that object across multiple data centers, across multiple availability zones inside that single region, right? And that's great for archival backup type scenarios. You're worried about where to store your database dumps, your log files, your code, things like that. A lot of those will end up in something like an S3, which has that high durability scenario. S3 is not necessarily great for every type of data access model. So let's say I'm running a database and I want to put my data partitions on a drive and I want to access those. Now we're talking about multiple processes that are reading and writing from common blocks. It's a block level type access pattern. S3 is much more of a whole file access pattern. So it wouldn't be great for your live databases. So if you're going to replicate data into the cloud because you want to have a warm standby database that maybe somebody could connect to in case of a failure, you wouldn't do that database replication to S3. You do that database replication to EBS, which is our elastic block service or storage. And that actually can be attached to EC2 instances, which allows you to allocate as much or as little storage as you need at a single EC2 instance, so you can actually have that storage underneath the covers. That is network attached storage. It has some basic durability baked into it. So when you think about putting something on an EBS volume, we actually do copy on write. We do multiple copies under the covers on that. So we actually have is written to more than one physical device at the actual writing time, which gives it a higher annual or lower annual failure rate than normal disk. On the site, it points out about 0.1 to 0.5% AFR, which is significantly lower than average disk, which is usually 4 to 5%. So you have a higher durability of that over a simple disk. However, that's nothing compared to the 11 nines of durability you get with S3. So as an alternative, as an additional safeguard, you can call snapshots on EBS volumes, which allow you to back up every block from that network attached drive into S3 to get the 11 nines of durability around that data, right? So you have a combination of mechanisms that are available there in the EBS space. One that's more of a real-time read-write, basic durability mirrored type scenario underneath an EBS volume, and then snapshots, which give you the high durability for storage over time. And obviously, when it comes to security, these are only accessible to you and your account based on your AWS Access credentials. And then should encryption be required, you can encrypt at rest by encrypting with S3, at store time or with our encryption, or using an encrypted file system with EBS type environment. So you can protect that data as well. How do you get data into AWS is obviously a big question. People ask, they're like, that's great. Now, how do I get my, 10 terabytes of data I already have lying around, or my 3 petabytes that I have lying around? How do I move that in there? And there's a few options there that actually exist in this space. One is we have an import-export feature. So the sneaker net is alive and well. You can actually take your drives, put them in USB 2.0 or eSATA network mountable, rack mountable drive arrays, and mail them to us. And then we'll actually take them out of the mailroom and we'll take them into the data center. We'll plug them in and we'll actually suck all the data off and put it into S3 for you. So if you have a large backlog of data you need to back up quickly, put them on a whole bunch of network drives or disk drives, mail us the disk drives, and we'll just suck them into S3, and then they'll be accessible to you. So that's certainly the virtual sneaker net is still alive. And then, of course, there's a whole bunch of continual backup products, right? There's a whole bunch of, software products and actually even hardware products, and there's many partners out here who actually have solutions around that allow you to slap a device or a piece of software in your existing data center, and then it automatically starts backing up that data, doing security encryption, doing deduping, and then continually pushing that information into S3 so it's then available on the other end for access in a disaster type scenario. Obviously, you can do things like replication directly over the internet if you want to, the EC2 instances if that's appropriate. There's a whole bunch of different products in that space. Things that do managed file transfer, scripted rsyncs, or Tsunami is a UDP-based blasting product that can actually pump data very, very quickly over a UDP channel with a TCP back channel for ensuring it all gets there. So there's a whole bunch of products in the space to sort of get you moving in terms of getting your data into the AWS platform. which is one of the initial challenges. The other thing people ask about is, what about my virtual machines? I already have a VM. It's already configured. It's set up. I love it. Can I use it? The answer is yes. Right now, it's Windows based today. So you can take a VMware VMDK, a Windows image. You can convert it to an OVF format, which is an open virtualization format. And then you can upload that virtual machine directly into our platform. And we will automatically spin up a Windows instance with that configuration, with that software on it, running on our platform. So you can take a virtual machine in your data center today, whether it be on disk or live, and pump that into our platform and get a similar instance running on the AWS side. So we actually have a process for importing that. Obviously, it's Windows today, and you can do that for both disks or whole virtual machines, so VHDs as well. It's Windows today, but that's obviously something we'll expand over time and continue to expand operating system support. Windows was the most common ask that we saw at launch, so that's what we started with, but we'll continue to expand that over time. So in terms of architectural patterns for when you think about disaster recovery and then what do I do in that type of scenarios, we have 4 major ones that we've actually seen, and all of them, as I mentioned before, it's a trade-off between the cost and complexity of RPO and RTO, right? Those 2 things are going to drive what the right choice is for your business. So the basic is backup and restore, right? I'm just going to back it up, and then it'll be in S3, it'll be available, and if a disaster occurs, it may take me hours to go spin up an environment by hand on top of AWS to get that data pulled into the right server types, to get the software installed and configured correctly, but it's there. It's safe, it's durable. I can respond. I can recover. You may have, depending on how quickly you can pump that data into S3, it might be, hours or days of data that you might not have based on replication speeds from your site into S3. And obviously, if you're doing like database dumps, you don't want to run a database dump every 5 minutes. So you're going to have to deal with whatever the speed is with which you can pump that data in S3 as your recovery point objective. But that's kind of your first level, if you will, of backup and disaster recovery. The next one is really much more of a pilot-light approach. And what this says is, what I really want is I want to have the data pre-positioned, but maybe the rest of the infrastructure is not up and running. So I want my log files, I want my code, I want everything out there and ready to pull into an AWS DR site. But I also want my database set up and running. I want data pumped into there. So when I spin up my web and app tier, that could come up pretty quickly. And then my data's been pre-positioned, so access to it and starting the application and cutting over could actually be more on the order of minutes to hours. The big win here is that your recovery point objective is actually going to be a lot lower because you might be able to be synchronizing data real time into a database in the cloud, right? So you might be only a few minutes or a few hours behind as opposed to, using S3 as a backup location. And then in terms of spinning up in the environment, it could be hours, and in some cases, actually, possibly, it could be minutes depending on how complex the environment is, kind of thing. But spinning up to all the other pieces besides the database is a lot easier, relatively speaking, right? And then, of course, the full functioning low-capacity standby, more about minutes. Now you're talking about a small, thin environment that actually has most of the pieces there. It's maybe taking some traffic, but not a lot. It's ready, it's pre-positioned, it's working, and you just have to spin up more capacity. And then multi-site is literally saying, I'm going to have a hot standby that's taking traffic all the time. So what are some pros and cons? The backup and storage, the pros and cons here, simple to get started. You're backing up into S3. You could probably actually get a product off the shelf through one of our partners that allows you to just start backing everything up to S3. It's done. It's pretty quick, right? It can be very cost effective. The only cost that you're dealing with here is then the cost of storage in S3, which is going to be, relatively inexpensive relative to the durability you're getting for something like that. So that's actually a low price point starting. And the preparation for something like this is to start, taking backups to the current system, storing those in S3, and then, building out maybe a manual that says, here's what to do in a disaster. Here's where the files are in S3. Here's the different operating systems you need to spin up. Here's the different apps you need to install and configure to get that environment back up and running. So the cost is fairly low here, in this particular approach. And, in case of a disaster, you just basically bring it up. You set up the new infrastructure in an AWS, DR site. You pull all the data from S3 and pump it into the right locations, whether it be the database or a file system on the web server or the app server. And once that's all in place, then you can switch over. You can cut DNS over, public DNS over to this new DR site, and then you get going. And so, objectives, RTO is really as long as it takes to bring up the new infrastructure. RPO is time since the last backup, basically, right? This kind of looks like this, right? You have front-end servers, app servers, databases, storage, all these things that are in your environment, and they're all pumping, code, logs, data dumps, data files, all that's being pumped into S3, which is, holding and maintaining your backup. Obviously all four of those arrows could be maybe one box that everyone's replicating to inside the data center, which is replicating out to S3, which is probably an easier setup for many folks. But fundamentally, this is what's occurring. You're backing everything up to a network-attached, storage device, in the data center. It's all then getting pumped into S3. Right. Pilot Light, obviously is that next level. Now you're talking about you're reducing your RTO and RPO. You're getting a little bit faster recovery time because your database is already up and running, which is oftentimes the slowest and most complex thing to bring up in most applications. And because you had your database pre-positioned, you could actually replicate data in more real time to that environment. So you've reduced both of those. It's cost effective because you're using very few resources. The always running resources are just a database or a couple of databases on EC2 instances, right? So you have an always on EC2 footprint, but fundamentally it's just for database replication. And then there's S3 for the remainder of those data. The prep is really to enable all the backup pieces. The other thing you want to do is actually pre-position or pre-create a whole bunch of Amazon machine images, which like you'll have a web server machine image, an app server machine image. They'll be pre-created, pre-installed with the right software, pre-set up to run your application, and then you just need to start them when the disaster occurs, right? So you've done a lot of prep work in this particular case to be ready to fire up. That also means there's more maintenance there, right? So every time you make a machine image, you then have to maintain it as your environment changes over time. But you're then, you're a little bit faster. You're a little bit more ready to actually recover in the case of a disaster. And then, of course, you might choose to use some reserved instances to lower your cost. If you've got an always running database cluster, you might churn that into a reserved instance type and then lower your price point. Fundamentally, it's just a pricing model around EC2 to consider for something like this. In case of the disaster, obviously you want to bring up automatically the resources you need, the web servers, the app servers, the database will obviously already be there. You want to scale the system as needed to handle production. So, you might have no boxes running. Now you need to go to 50 or 100. You'll want to obviously scale that up quickly to be ready for it. And then you want to switch over, obviously. So recovery time objective is basically the amount of time it takes to detect your failure plus the amount of time it takes to spin up your web app tiers for your application, right, added together. So now you're talking about minutes, possibly, depending on how complex the environment is, you can imagine it could be hours for coordination between nodes, things like that. And then the recovery point objective, it all depends on your replication type. If you're trying to do real-time, and it's possible to do real-time synchronization, log shipping from your on-site data center to AWS, then your recovery point objective could be in a matter of seconds to minutes, potentially, right? If it's only possible to maybe do some, slower asynchronous log shipping type scenarios, you have to pump logs and then pick them up on an hourly basis, you're going to be stuck with whatever you can get from there. So it's going to come down to your pipe and how fast you can get that data moving. And that's going to look more like this, right? So down at the bottom, you've got your data backups occurring, just like we had before. Up top, you've got some pre-canned AMIs that you store. So when you build an Amazon machine image, we store that machine image in S3. So that's ready for you to start up at any time. And then you've got some real-time replication database instances sitting there taking traffic to get the database pumped over and those database rows and inserts done, right? And then, of course, you've got your full functioning low-capacity standby. Pros here, obviously it's already taking traffic. So by low capacity, we mean that it's actually taking some amount, like 5-10% of your traffic. So the pro here is going to be that it's already ready. It's already taking some of that traffic. Now, it can't handle full production on failover, so you're still going to have to scale out. But it means that your environment works, right? This is the one nice thing here is that you've already got an assurance that because you're taking production traffic and some percentage of it, that your environment already works, which is kind of a nice thing. It's a little more complex, I think, because now you have to think about what do the 5% of traffic might go over here. How does that relate to the 95% that's going over here, and how do we keep that data in sync between those environments? So it can be a little more complex to set up and maintain, but at the same time, it gives you much greater assurance that your DR plan will work. because you've already got an environment taking traffic, so you're sure that it actually runs your application, which is always a key problem in the DR world, right? DR is great until you actually have to use it, and you find out you forgot something. This is a scenario where it says, don't forget, just keep it running at a small amount, and then therefore you know that it's going to work, because when you have to cut over, you just have to scale out, as opposed to knowing you have to sort of build out or configure something, right? Similar to the Pilot Lite in terms of setup and prep, the difference being that you're going to actually run all the components in the architecture. So app, web tier are going to be there, and maybe small footprint, and then you're going to go ahead and scale out on failover. And this is sort of a best practice here is continual testing, trickling various types of transactions to make sure it's always running. Taking an always running amount is actually nice. Depending on synchronization of data, that may not be possible. So maybe it's the ability to cut over and trickle in a little bit of traffic every once in a while to make sure it's still up to date, kind of thing. Right. So in case of disaster, obviously, you fail over critical production systems immediately to the new environment and start scaling out, right? Automatically update and point DNS over this new environment, start scaling out as fast as possible. And obviously, you want to build out the auto-scaling mechanisms if it's possible for your application to scale out automatically for you the minute traffic starts showing up. That'll definitely make it a lot faster to sort of respond to the traffic as it cuts over, kind of thing. For recovery time, it's going to take, obviously, there's some component of scaling out time to sort of scale out to be able to handle all that traffic. That'll be on the order of potentially minutes. And then, of course, if there are, for recovery point objective, it's going to depend on your replication. If you're doing real-time replication here, again, if you're able to pump that data real-time between the nodes, it could be seconds, right? I'm hesitant to say 100% in sync unless you're doing, actually commit on write across multiple data sources. But it can be, depending on your data load, it can actually be essentially accurate, depending on the amount of data you can pump across that pipe for replication, right? And this looks a little bit more like this, right? You've got a zero-weighted DNS route pointing to your new disaster recovery environment. You've got auto-scaling groups wrapping, your front end and web and app tiers. And then that means the minute that traffic starts showing up and starts pumping through, those environments are going to start scaling out automatically. And DB replication is happening in a real time, to that database node. And backups, of course, to S3, right? And then the last one is a multi-site hot standby. Possibly, the most complex to set up and be running, because you have to think about how do you keep data in sync across multiple sites, and that can actually be really challenging depending on your data set size. But this one is fundamentally gives you your highest availability. It actually starts blurring the line between disaster recovery and high availability, because now you're saying, well, guess what? There's never going to be a true disaster, because I'm just going to start changing the amount of infrastructure available at any one site. So as failures occur, data centers go out, I can just move traffic around and just rescale automatically. So it starts to look much more like a high availability solution than just a disaster recovery model, right? At any point, you could take, obviously, production loads, it's ready. If you want to be incredibly conservative, you can actually even pre-position hardware, much more hardware than you would need to be able to cut over dynamically. It's very similar, obviously, in prep to the low capacity, with the difference being that maybe you've scaled out things a little bit more to the environment to be ready to take that production load at more of a moment's notice. In case of disaster, it's really much more about setting up and changing DNS and saying go from here to there, point over, because you've sort of done all the hard work to make sure that they're in sync. And of course, the RTO is basically DNS update times, how long it takes to fail over between the environments. And then, of course, recovery point objective again, because we don't know the size of your data set. Hopefully, it's seconds. It could be totally in sync depending on the amount of data you have to replicate across those sites. Right? And this is kind of what that looks like. Obviously, it's similar to the last one, with the fact that you just have more resources pre-positioned and ready to go. Kind of thing. So some of the best practices that we've learned sort of for being prepared in this kind of environment, or this kind of problem, is really starting simple and working your way up. Right? Obviously disaster recovery is a fairly, we've tried to make it look, I wouldn't say simple, but like fairly straightforward, some of the choices, but the mechanics and the actual details, to go through this are going to be complex. So you want to work your way up the chain, fundamentally. Thinking about, okay, well, what's my backup and recovery strategy? Let's test out the backup and recovery works. Okay, let's move up the chain to sort of making sure we got DB replication. Is that working? Okay, let's move up the chain and start doing pre-positioning of machine images. Let's make sure that works. So really not trying to boil the ocean all at once. Testing as you go along, I think, is critical. Obviously, software licensing always gets interesting here because now you're dynamically spinning up new instances, running software that you were running in a production environment. In some cases, those software licenses already account for a disaster recovery type scenario where it says, oh, if you're running it here and it fails, we won't charge you for this extra license over here because we know you're not going to run it unless this one fails. If you're going to do a multi-site hot standby, you may be running 2 licenses at the same time, and now you got to think about what are the licensing changes there and costs from that perspective. It's always important. And the one thing I could say over and over again is just exercising your DR solution. The idea of game day, which is I don't know if it's a common industry term, we use it a lot inside of Amazon. The idea of literally testing your DR by intentionally breaking your environment. And then having somebody who knows what's going to happen test somebody else that doesn't know what's going to happen by breaking their environment and testing those kinds of scenarios out is actually, it sounds cruel, but it gets you ready fundamentally for those kinds of scenarios. There's actually a great blog post by Netflix, who's a big AWS customer, and they have a concept called a chaos monkey. It's a good name, actually. But what they do is they literally have a script that runs around shutting things off randomly, testing things out. And so, it sounds like a horrible, evil thing to do, but fundamentally that means that, if there are challenges in their environment, if applications do die, if servers fail, they don't have a problem. They survive and they weather all those storms because they've essentially tested all the scenarios, because they've, shot themselves in the foot intentionally, I think is the way to think about it. And then, of course, obviously, ensuring your backups are working by recovering from them every once in a while, checking the integrity of the data, things like that. Make sure that, what's out there is obviously it's a file name and it's something. And once it's in our system, it's durable, but then pulling it back to make sure you're backing up what you thought you were backing up, things like that, double checking on that front. And then monitoring, obviously is a key piece here because monitoring is going to be what enables you to cut over fastest, right? That's what's going to alert you that there's a problem and that you need to do something, right? There's a whole bunch of solution providers. There's a whole bunch outside, and this is actually a space where there are, in addition to the platform and the tools and functionality we provide, there's a whole bunch of people that can make this a lot easier for you in terms of, on-site application components, in terms of backup tools and technologies, in terms of even, virtual machine migrations that go beyond what we can support in the VM import space. There's definitely people in that space that really actually can do a lot of fun stuff for you. And of course, you can see there we have a solution providers site. So aws.amazon.com/solutions/solution-providers. And that actually has a lot of these folks, and they're broken down by category, so you can see who's there and what they're running and what they're capable of. And, all I know is there's a lot of history in this space that goes well before us, and there's a lot of partners that actually are making this a lot easier on top of our platform as well. So I think this is, sort of the conclusions. We obviously have a whole bunch of building blocks. You got some fine-grained control over what you want to do. You can scale up rapidly when needed. So you don't have to necessarily pre-position a whole bunch of hardware for this kind of scenario. You pay for what you use and only when you use it, right? It's kind of a nice feature, especially for DR because, this is the 0.01% of the time that we're talking about. So putting a lot of cost into that may not be worth it, depending on your business scenario. And of course, having the ability to test this easily through our environment is kind of a nice, be able to shutting off a server. It doesn't have to send somebody into a rack room somewhere to flip it off. With ours, it's just an API call to pull the plug. So you can test things in terms of failures pretty quickly. And of course, we have multiple locations worldwide and a whole bunch of solution providers to help you get there. So, cool. Question?
Yes. Slideshow is where?
It's on this laptop right now. Sorry, that was me being a pain. We will make all the slides available, actually. I need to check with Reed on the exact location. Reed's right there. These slides are going to be available, yes?
They go to the main event page, that event, and
okay.
To our content site or
right.
the event page.
Got it. I will just say what you're saying on the mic, right? So
It's maybe up there right now, but
yeah, not sure. So it'll be aws.amazon.com/Fed event, all one word, lowercase. And then on that page, there will be a content site where the slides will be posted. If they're not there right now, they will be soon. And you can download all the presentations from today that we presented. So, yes.
This is kind of, you actually showing the presentation to sort of follow, but DR, is there any provision or thinking about having a Gov cloud site in the other pieces?
Right. So the question was on the DR front, is there any provision or plan to have a Gov Cloud oriented site in another region? So we're going to continue to expand our region footprint, and I don't think it would, so I don't have any dates or commitments for you that I could say, oh yeah, it's going to be here on Tuesday. I can't, I don't have that information for you that I can share. But if you look at our footprint over time, how we've been expanding, we continue to launch multiple regions, and in fact, we've launched one or more region, per year for the last few years. We're going to continue to expand our footprint. So I think without giving you a date or a firm commitment that says, yeah, it's Tuesday, I think it makes sense. So yeah, it's likely it's going to happen. I don't know when, but obviously we have one now, and that I think is a start point. But we think the whole reason for creating that region is we think there's a lot of opportunity in this space, and there's a lot of additional requirements you guys have that we want to fulfill. So I see that as being an ongoing commitment as in terms of short-term one. So yes. What's that? Are the snapshots, EBS snapshots incremental? Yes. So the first time, let's say you have a 1 terabyte drive. The first time you call snapshot, the 200 gigs you're using will be backed up block by block into S3. Let's say you make 30 gigs of changes. So this now subset has been changed. And you call snapshot again. We're only going to back up the 30 gigs of changes. Right? So every snapshot we make after that will be an incremental from the last. Now, what's interesting about that is then somebody has asked me this as a follow-on question. What happens if I delete the first snapshot? Doesn't that destroy all the incrementals? No, because what we do is we maintain a database of which blocks belong to which snapshots, that are still active. So if you deleted the root snapshot, the first snapshot, and there was a block in there that changed in the second snapshot, and you didn't want that root snapshot, then we could delete that one block, but we can't delete the rest of it because there's many blocks that still belong to a recovered second snapshot. So we'll maintain that consistency and understand at a block level which ones belong to which snapshots, so we don't accidentally delete or corrupt your volumes. Okay. Question? The question was, do you have scripting code to switch your DNS for you? So our DNS service, Route 53, is an API, right? So you could write a script against our Route 53 API to cut over DNS and switch it from here to there, kind of thing. I don't know that every DNS provider has that same capability. I know that everything we build is fundamentally an API and is scriptable. Now the choice to failover is yours, so we don't failover automatically for you. So that would mean that you'd have to detect the failure in environment A, run your script, which responds maybe to an alarm, and cut over to environment B. Oftentimes, the choice to cut over from environment A to B is one where, because it's such a fundamental shift in terms of where resources are, in terms of how traffic's handled, a lot of times people don't necessarily do that in a fully automated way. They might choose to have one step of manual innovation to say, are you sure you want to do this? But it's totally scriptable, yes. Mm-hmm. I can take one more question. That's what Reed said. It's not my rule. Yes? No. So the question was, if somebody accidentally deletes a file in S3, do we have a way to recover that? And the answer is no. So we're faithful to your delete command. So actually, some customers ask us the flip question. They say, well, how do I ensure that you really deleted it? And it's like, no, we really delete it. We don't hold on to it for later, thinking maybe you'll want it back. So there's ways you can protect against that. If it's a small number of files, you can enable a feature called secure delete that literally requires that you have a multi-factor auth token, like a key fob, and you do it through the console and type in a 6-digit number to delete it, right? I wouldn't do that for everything because it can only be done by person. And so if you had thousands of files like that and you want to delete them all, you'd have a lot of busy people with key fobs running around. There's also a versioning feature that allows you to actually enable versioning for a file or a bucket. And what that does is when you call delete, it will delete the most recent version. So when someone tries to hit that key, it'll be gone. But you can recover the last version, which actually is the same as the most recent. So we always keep a version ID against it. There's the generic one, the no version ID, which points to the most recent. And then if you delete it, just all it does is clears that out. So your most recent's still there, but only if you access it with the version ID you're expecting, right? So you can get it back through that feature as well. So there's two kind of approaches to that. Mm-hmm. You can also turn off delete, right? So you can also use an IAM user, an identity and access management user, for all of your S3 access, and then you can literally disable the delete command, which works too. Yeah. All right, that was the last question. Sorry. All right, well, thank you very much. There's more to go from here. I don't know what's next. But thank you.